Okay, so for those of you who are brand new today, this is the ScHARe platform. We is a cloud platform that focuses on population science, social determinants of health, environmental and behavioral types of data sets. And the focus is also to do advanced health disparities research, health outcomes research, using big data and especially Python. And today's speaker, Cynthia Sheffield, is going to help you with Python. This is not a Python course. It is what I call a Python prep course. So what I mean by Python prep is that there's so many terminologies and things that, you know, if you sign up for the Python course, that if you don't know what that jargon is, you just kind of, your eyes gloss over and you fall asleep. Well, that's what I did, okay? So I'm saying this from experience. So the Python prep course is really geared to helping us know what that terminology and kind of the jargon, so that we don't fall asleep and we actually can follow along and pay attention and actually learn for the course. And Cynthia is very good at explaining this in a way that even I got it. So I know she can help all of you. We asked her to come back because the first session only covered so much of the information. And we really wanted her to, we're going to ask her to recap the Python information she did last time, and then go into detail over the Python information that she skipped or went over quickly. But I want to also explain to you a little bit about ScHARe before we get started. This is the stuff that Luca already went through. This is a collaboration between the Office of Data Science and the National Institute of Nursing and the National Institute of Minority Health. Of course, there's many people that we have to thank to get us to this place, because this is a village effort. So one of the things that we also want to do today is to use to get polls. And so I'm going to ask Kevin to also give you intro into Slido, so that you can also fill out the polls and put comments in as well. So, Kevin?
Great. So can you see the slide here? Perfect. And so we are going to be using Slido today, as Dr. Duran mentioned. To use Slido, you can either download the Slido app on your phone or simply go to slido.com on your phone or computer. Or alternatively, a very easy way is to just simply scan the QR code that you see on the screen here on your mobile device, and that will bring up the Slido for today's session. To join today's Slido via the website, via slido.com or the app, just go to slido.com and then use that code you see here, Python 2, where it prompts you to enter code here. For those of you
For those of you who want the easy way to do it, Mark put a link in the chat.
Absolutely. You can also click on that link that's shared in the chat as well. And so when we get to time for to do the Slido polls, the code will be displayed on the screen. So even if you aren't able to click that link yet or have it pulled up quite yet, you will be able to once we start launching the polls. And so with that, Dr. Duran, correct me if I'm wrong, but we should just launch right into the first poll that we have for folks today.
Yes, please.
Great, and it looks like we already have a good amount of responses. So go ahead, fill out that poll, and we will take a look at the responses once Dr. Duran is ready.
Please fill out the polls because it really helps us to make sure that we're hitting the right information and helping people the best we know how to help. So this is a way for us to get feedback as well. Okay. So it looks like we're pretty good with this. So I don't want to spend a lot of time on the polls going over them because I want a lot of time for Cynthia to give you Python stuff. So let's stop sharing that and we'll go back to the presentation. The Slido will stay open, so feel free to do the polls as much as you can. So do I need to take it back?
Yes.
Okay, see the screen? Okay, so let me do a quick overview of what ScHARe is so that you know that what we are linking into in the Think-a-Thon is actually the ScHARe platform. So that is what you have been getting guidance into doing. So you want to be on this platform. So the purpose of ScHARe is to increase the participation of women and underrepresented populations. This often includes racial and ethnic minorities, low SES, sexual gender minorities, rural, people that have trouble getting into the mainstream access and who are very underrepresented in the data science fields. We also want to create a paradigm shift in how we think of health disparities research. We want or health outcomes, healthcare delivery research, because AI is not going away. And it's dominating the fields of research more and more in every field. So we need to help the health disparities, population science, social sciences, behavioral sciences actually catch up to the use of AI that basic science has been doing. And another aspect which we will be getting into next year is really dealing with bias mitigation and ethical inquiry into the algorithms that drive AI. The ScHARe components, we have data sets. We're launching a data repository in the next month or two. It has all the computational tools that you will need, including many pre-populated notebooks that allow you to just cut and paste Python code and R code in order to run analysis, so you don't even have to learn some of the coding in order to start using the platform. And we are also in the process of integrating SAS, which is a statistical program, onto the Terra platform so that you can run analysis and do things even to prep for doing AI. As I mentioned, we have data sets. Many of our data sets, there's 3 different types that we have on here. One is what we call Google Cloud public data sets. Those are your big national data sets that has all PII, all personal information scrubbed out. So these are very open to everyone and easily accessible. We have ScHARe hosted public data sets. There are some data sets that we upload onto the platform and we have to host them. An example of this is BRFIS. And for those of you who don't know, BRFIS is the behavioral risk factors, but there are many others like that. And then the last part of the data sets that we'll be adding at the end towards the end of this year is all grant funded, contract funded data sets. So this is going to be a repository to hold social science types of data sets. The data sets are organized by the social determinants of health categories that CDC uses. We felt this is probably the best way to sort of get at the social determinants of health. data that is often being requested. And it's organized by economic stability, education, healthcare access, neighborhood and built environment, social and community context. We also have health behaviors and disease and disorder types of data sets as well. Of course, we have all of the tools that you need, like BigQuery, TensorFlow, notebooks, workflows, etc. And this is a way for you to do this type of work in a centralized location instead of right now jumping all over everywhere. I also said that we're going to start this year. This is, we're slowly building into this. We're trying to get you all prepped in Python and big data so that you can actually do the bias mitigation work, which is important in order to stay ethical AI. So I'm going to stop right now to make sure that Luca got everyone registered.
I did, Debbie. And so everyone who provided an email address has been registered. So what I would ask you now is to go over the same steps that I explained and, create a Terra account if you haven't before, and let me know if you can see that notebook.
So
I'm going to help you in the breakout room.
So if please put down your hands now, if your hand is up. So that's Cynthia, Olafunke, Nia, Jane. Some of you put down your hands. Now, what's going to happen right now, I'm going to ask Kevin and Mark to put everyone into a breakout room that didn't get to the playground mode and developing your workspace that Luca did in the first part of this presentation. Luca will go into that breakout with you and help you get to that place. So even those of you who just got registered, you may want to go in there with him if you didn't follow along and do everything. And so Kevin or Mark, please move anyone who's raised their hand. So please raise your hand so that they can see and take you into the breakout room with Luca. Okay? And we're going to move on. And he will help those with their hands raised in the breakout room. Okay.
Perfect. Thank you, Debbie. Just a reminder that if I'm busy helping our users, the rest of the audience just has to click on that link, right, that Kevin pasted before to access the notebook so that Cindy can go on with her part. Okay.
Okay. So we're going to go back to the presentation part now while they get into the breakout room. So it's part of the presentation, phase 2, which is the phase that we're entering now on the ScHARe platform, is about the data ecosystem and the repository. So what we're doing here is we are the first institute in conjunction with NINR, the Institute of Nursing, to develop core common data elements. These core common data elements are actually being used so that we can be proactive in data aggregation and data harmonization. By doing this, we're going to be able to link many data sets together and create a better ecosystem and PII safety. So what this means is that if we have core common data elements in each of these projects, so this is an example of all the projects over here, all the little hexagons. What it allows us to do is connect different projects together easily. So mental health with smoking, or diabetes with applied clinical, and it creates these data sets that are aggregated. It can be for both intramural and extramural. We are also taking surveys like national data sets like the American Community Survey And we're actually coding the common data elements to that survey as well, so that we can link national data sets to individual projects. And the last innovative part that we're doing in this platform is that all the other platforms at NIH cloud platforms deal with basic science. So Anvil is genomics. Biodata Catalyst is pretty much all the other biologies, omics, all the biologics. All of us is an ancestry, genetic, social determinants of health. They just added into this. And then ScHARe, which is more of the social sciences. So we have 3 basic science and 1 social science. But what we all have in common is this Terra platform. Because we all have this Terra platform in common, we are linking across the platforms. The one that we're working on right now is ScHARe with Biodata Catalyst, but we will be able to link with all the others as well. In order to stay updated about what happens with ScHARe, you just go to our webpage, which is the nimhd.nih.gov ScHARe, and click on Stay Tuned and register your email so that you can get all of the updates that we do and the announcements of new Think-a-Thons. So we're going to do this poll now. If you can, Kevin, take over and do Slido. And basically what this poll is asking you is, why are you interested? This is an important question so that we know which directions to go. Again, Mark has put the link into the chat. So all you have to do is click on it, and then it can automatically upload, and then you can choose your decision. This helps us to know what steps to take next. So if you can please do that. And again, I'm not going to go over the results and stuff now because I do want more time with Cynthia.
Great. So I will leave this up, but I will turn it back over to you, Dr. Green.
Okay, can you see my screen again?
Yes, we can.
Okay. So this last part of this before we get to Cynthia is to let you know about the Think-a-Thons structure. So these are monthly things that we do now. I'm going to tell you that for next year, they're so popular that we're actually going to end up doing 2 a month. One on the tutorial, which is what we have right now. This is a tutorial type of Think-a-Thon. In other words, we're teaching you how to do things in data science and cloud computing. And today's is focusing on Python. Next, the other type of Think-a-Thon that we do is research collaborations. So that is why we're going to start doing 2 a month, because we also encourage all of you to join a research collaborative team. We will use the ScHARe platform data to launch a project. And in that project, we'll have different levels, career levels, as well as skill levels from multidisciplinary areas. And we will help you walk through how to do a research study using big data and on the ScHARe platform, and take this all the way through to a publication. So we really want to encourage you to also participate with this. So as we move into Cynthia's presentation, why do we learn Python? We're encouraging you to learn Python because it is the #1 language that is used in algorithm development, data science, cloud computing now. You can use R, and there are many things in R that is there for you to pay attention to. But Python is the language. I gave a presentation and I said something about everyone learning Python. Well, I can tell you as a director, I do nothing, but I have to review everything. So what I encourage all of you to do, even if you're a senior investigator, you have to at least know what they're talking about. So the words you're going to see are things like NumPy and Pandas and SciPy and scikit-learn and PyBrain. Well, because of that, if you don't know those terminologies, you're going to be lost in what your coders and what your algorithm developers are doing. And then consequently, you're not going to know if it's ethical AI and if it's actually achieving what you need. So it's important that you at least have an understanding of what Python is. Even if you are not a programmer, even if you don't ever plan to code, R is the other language that is used. Many of you may already know some of R because it's also a statistical package. There are notebooks and things that we have on our platform for our users as well. And it's perfectly okay to use R to do data science, cloud computing, but Python is the dominant language. As we said, most of them are Python. There are many free courses available to you. There's also courses you can pay for, but I've done the pay for and the free, and I saw no difference between them other than an instructor can sometimes help you. But if you're good at sort of self-learning, you can easily take the free ones without even paying for anything. And the reason Cynthia is here today is because of this one thing, unfamiliar terminology. It is the barrier to learning. And that's why Cynthia is going to help us do this. So one of the things that Luca asked you to do at the end of his initial presentation at 2:30 was to click the playground mode so that you were creating your own workspace. So I hope many of you did that because you need that workspace in order to do what Cynthia is going to ask you to do. So I want to introduce our guest speaker, Cindy Sheffield. She is helped us last time. She's at NIH, also in OD, in the Office of Research Science. Cindy has many accolades and to help in her career path. But the one thing that I think is most important that I so appreciate about her, because I was once that naive, I don't know any of the terminology, Python user, people scared to learn. And she made it so simple that I actually got excited to learn it. So that to me, I don't care all of her achievements. That was the one thing that I asked Cynthia to come do for us, because if she can do it for me, she can do it for the rest of us. So Cynthia, I'm going to turn this over to you.
Okay, terrific. Thank you very much, Debbie. I'm thrilled to be back here just to kind of reinforce many things that Debbie already said. When I was at Hopkins Medicine, we often looked at studies and said, wouldn't it be great if we could compare this data together? And I love that this ScHARe environment is doing exactly that. It's allowing you to pull in data sets so that you can compare data and make more precise decisions about healthcare. So I'm very happy to be part of this. I too was a very new Python learner last summer, and my Python skills are not, advanced in any way. I'm still very much in early learning phases. Also to, excuse me, also to reinforce what Debbie said, you can learn a lot of Python with self-learning. Actually, if you have a specific question, just basically trying to Google that answer and using the resources that you're aware of, many that will be provided through this program, you can often find the answer to your code. So with that introduction said, let's go back to the code that we were looking at last time. Let me see if I can, magnify. First of all, share my screen. Let me make sure I can share my screen.
Want to take it over now?
Yeah, I'll go ahead and do that. And I also want to make sure that everyone can see my screen. So if someone, perfect, thank you. So when I was here last month, we talked about a lot of the concepts, syntax, variables, functions. I'm going to go ahead and turn my camera off just to, so that all of you are able to watch the code and don't have to worry about me. But anyway, we talked about a lot of concepts, syntax, variables, functions, data types, and conditions. So within this code, we'll look at loops and if statements as conditions. And then we also talked about different libraries that you can pull into your code. Many of them Debbie just mentioned: Panda, NumPy, visualizations, libraries, other libraries like Matplotlib and Seaborn for visualizations. So we'll take a look at those as well. And just so you know, there is a ton of libraries out there at pypi.org. So feel free to go explore that after. I'm so sorry, I have some background noise here. So again, feel free to go explore that. So with our code, let's talk about the, I'm sorry, I need to have someone exit my room. 1 second.
And for those of you who are on the call right now,
so sorry, I usually have someone who just sleeps in the office, but this time she decided to be vocal. My apologies.
For those of you who are just following along, you don't actually have to have access. That's only if you want to do hands-on. She's going to give you all these screens to show you, so you can just pay attention instead of trying to, do everything. And again, let me remind you that this will be posted on the NIMHD webpage in the links that Mark and Kevin put in the chat. So you can always go back and look at these videos as well. So I'll go back to Cynthia.
Okay, terrific. Thank you, Debbie. Thanks for stepping in. Again, when you have any Python script, if you're using it on Google Colab or here on Terra, you're going to need to initialize your Python code. And that's what this cell here is doing, just going ahead and initializing code. And this is actually acknowledging some data sets that we'll be using later on this code. I'll be using an iris data set, and as well as a data set called trim_data_JT. So just to let you know what that code is here. This is actually, this is just a description of what this code does. You want to set a markdown or descriptive code or descriptive statement when you create code, any code, even as you're learning how to practice. I strongly recommend you get in the habit of saying, this code will perform this function and it might use these data sets and its purpose is whatever, and you need to make sure you do X, Y, or Z if there's something unique about your code. You can also do this for each cell. Notice that you can create notations by just using the #. This is example 1, create a welcome message for NIH. So this is code that I created. The code starts with this variable. We talked about variables in the slides last month. So this is a variable, just str, and equals, and then within quotes, hello Think-a-Thoners. And then the next line of that code is print str. So if we go ahead and just run that particular cell, whoops, oh, you know what? I did crash a little bit. I'm sorry. It will take a couple of minutes. I did notice that it went down and I thought it came back completely back up. I need to open my cell. As many of you had to open your Terra workbook, I'm having to reopen my workbook here. And Terra is a huge machine, so it takes a little bit of time. Go ahead, Debbie.
Cynthia, I was just going to say, this is exactly what you guys did in the beginning, where you hit the playground mode and then you hit the notebook part. So her notebook crashed and she's uploading it now.
Yes.
And this is, we asked Cindy to go over this again, because we know that many of you were not on the call last time. So that's why she's trying to explain, you know, what codes and strings and stuff like that are. And for me, it's a good refresher.
Yes, so yes, if many of you are familiar with code, if some of you are familiar with code, this will be a bit of a repeat for you. And if you were able to go all through the code and completely understood it, again, it will be a review for you. But my aim here is for the new novice learner to gain a better understanding or some reinforcement about code. So anyway, here I have this
Just
string.
one little second, and because you have it up on your screen as well. When it's saying error starting to compute or unable to edit analysis, it's because there's too many people going on at one time. Remember, Luke is in another room doing this. So could you just close those out on your screen, Cindy?
Absolutely. Okay.
So again, just so as you saw on hers, it was up there, but then she got back in. So that's what happens.
Ooh, so actually, I'm not
You
sure
wanna
if
run
I'm
playground
in.
mode.
Yeah, I'm not sure if I'm in because
You want to run in playground mode. Yes.
yeah.
Now, let me explain what that means. So the reason you want to run in playground mode, because think of what the word playground means. It means that everybody's sort of in the same sandbox. So now we can do this all together because we're in a playground. If it wasn't a playground, you couldn't have everybody in the same space. If it says refuse to connect, you just have to wait and do it again because there's so many people in the mode, it just makes it delay. So just as you saw all the things pop up on Cindy's screen, look, she's in there anyway. So you just have to be a little patient and let it go. Click on playground mode and it'll get to this notebook. And the notebook you want to be in is the Jupyter 10 Python Code Basic Workshop copy. Okay.
Okay, so again, because I've just refreshed this notebook, I'm going to need to reinitialize my data sets. So I'm going to go ahead and click on that. This blue indicates that it's in edit mode. It needs to actually be in green mode. Let's see. Let me try cell, run cell, see if it switches over. So I'm a little locked up on this. Let me do. Let me go back to file, revert. No. Let me try getting back into my analysis. Let me try this again today. Open. See if it'll let me run. Nope. Try this one more time. see, I created another version earlier. Let me see if I can get into that one and use that one. Maybe fewer people are on that one. Okay, this is what we'll go for. I'm just going to adjust. Notice my table of contents over here. I'm just going to narrow that window down and go ahead and run these data sets. Let me get rid of these error messages. Maybe that'll do it for. All right. So
I just asked Mark and Kevin to bring Kevin or Luca back in.
thank you so much. Yeah, I'm not sure why it's not initializing me back to my original script. And I'm just not that familiar with Terra to be able to navigate it independently. I imagine I need to go somewhere like this.
Mark, will you put me in the breakout room, please?
I just closed the breakout room, so
Okay, good.
everyone will be coming back in shortly.
Okay. Maybe try this one. And this is the life of encoding. You find errors and you keep going. You keep trying to. It's for some reason not. It wants to put me in just edit mode, not run mode. And I'm not sure.
Mark, I need everybody out of the breakout. I need Luca back into the main session. Luca, we can't get into the run part. We can't get into the notebook. You're muted.
Oh, Cindy, you can't?
I cannot. No, it
cannot get into
crashed.
it.
It
Can you-
crashed on me, and then
Okay,
I
don't worry.
can't.
Can you please go to the analysis tab?
Sure. Wait a minute. Let me get.
You can click on workspaces.
Okay, great.
Mhm. And then if you scroll down, okay, share Think-a-Thons. Then analysis. Okay.
And so for those of you who are already there, you can hit run button and select a cell. That is what you should do. We're
And
doing
see-
that, it's not working, and that's why we're backing up.
Mhm.
But for those of you who've already done this and we're already prepped, yes, all you have to do is run the cell and you got it. You're good.
Cindy, can you use the third one? It's called 10 Cindy updated. Please
Yeah,
use
I
that. That
started.
shouldn't change.
Yeah, I started to use that, but it wasn't going to let me into the full code. Now it just did. Okay,
Yeah,
see, we
perfect.
just
That's
needed
a backup
you
copy that
here.
I created.
Yes,
So
we just needed you here. That's all.
I know that happens because too many users are trying to access the same
Right.
thing at the same time. So I created a copy for you so that you will be able to run.
Perfect. Thank you. Thank you.
Of
All
course.
right. So now let's see if I can go ahead and start running some of these cells. So just go ahead and hit Control Enter. Again, this is an example of a markdown cell where it's just descriptive information. So lots of code is generated out of that scripted. And now we're here to our Think-a-Thon PyCode basic script. And again, it's an explanation of the script, and now we're to our first code cell, and I should be able to go ahead and hit actually Control Enter to go ahead and run that cell, and it should generate the print below. So what I've done here with code is just created a variable again using quotes, hello Think-a-Thoners, and then printed that string. And then the next example, I created two variables and printed those. X equals 4, Y equals 2 times 5, and it generated those outcomes for me. And then we had our third example where A equaled 1, B equals 0, and C equals A plus A plus A plus B. And that generates a value of 2. So I'll let you guys go ahead and play with that code to see if you're able to actually generate that code. And I'll look at messages in the chat to see if there are any questions. Okay, so some of you are getting an error message. Oh, okay. So connection messages are kind of beyond what I can address. Okay, fantastic. Somebody was able to print the string, so that's great. Okay. Great. It looks like many of you are in and starting to play around. So again, if you can, you should be able to have the code directly already created in your cell and just go ahead and run that. So, all right, and hopefully all of you got the same answers. The next demonstration was to create a tuple. And again, many of you may recall from last month, tuples are ordered structures of items in a list. So there is an absolute order to whatever that list is. I often think of math order, my dear Aunt Sally, where you have to use multiplication, division, division, addition, and subtraction. This problem actually bears on that. That's a bit of a trick answer there. But anyway, here's a tuple where we're creating it in an exact order. We know it's in exact order because we don't know it's in exact order, but I've put it in alphabetic order so that it demonstrates there is an exact order for this particular tuple. So I can go ahead and run just that line of code. And then generate a list of all of my items within that particular tuple. So apples, bananas, cantaloupes, and dates. If I wanted to, and so I printed just fruits tuple, the variable itself, this tuple. I'm just going to close that. And so it prints all of the items in that particular tuple. Then if I say print fruits tuple and just print 1, the value of 1 within that tuple, then I am only printing the value of bananas. The reason being is because Python counts items within a list or a tuple or a directory. Luca, do you know why I'm getting this message, and can I get it to stop?
Oh, Cindy, can you reload, please?
Okay. Thank you.
Mm-hmm.
Let's try reloading again.
Again, some of this is because there's so many people doing the same thing.
Yeah, that's the reason.
It's kind of good though, because when you're working on your own and you get some of these, then you kind of know what the error messages are about.
Exactly. Yep, exactly. So anyway, back to our example with tuples. So whether you have a tuple or a dictionary or a list, any of these data structures, Python will look at apple as item 0. Bananas will be 1, 2, 3. That's just the way Python works. Any ordered list is going to start with 0, not with 1, but with 0. So when you go ahead and print that particular item or run that particular cell, it's going to print all the items in the cell, or in this instance, print tuple, just item 1, it will print bananas. But if I say print fruits 1 through 2, it actually, notice here it just says bananas. Here is the result of print tuple 1, bananas, but here is the result of print fruits tuple 1, 2. My apologies. We'll let it reload and settle. Oops, a little too far down this time. So again, so here's just the plain code, print fruits tuple. Let me see, can I do, is there a function key for printing just a single line?
You can select it and just run that.
Okay. This wants to run the whole cell, but that's okay. Will Control Enter on the single cell selected do that?
There should be a button actually that allows you to run it.
Okay. Let me try this. Okay. Here are our 3 results. I'm going to go ahead and just kind of move on.
Cindy, it's important that you are the only one using this notebook. So everyone else who is using this should,
Stop.
stop.
Please.
Yeah,
Please stop. It's great to have hands-on, but we will have hands-on exercises in a few minutes. So let me walk through this code and demonstrate it, and then we'll get to the hands-on portion. So anyway, back to our tuple cell. So here we have a cell. Let me run this whole cell. Here are the results from these cells. So again, I created the tuple. I printed this line, apples, bananas, cantaloupes, and dates. That's just printing the whole tuple. Then if I just want to print a single item, this is the result, just the word bananas. But if I want to print a range of results, notice how this is appearing differently, even though it's just the word bananas. I'm going to close that. It's actually the range 1 to 2, but the range 1 to 2 in Python is 0, 1, 2. And again, the way Python works is it will count 0, 1, 2, but if you give it a range 1 to 2, it will stop with the item right before the last value you give it. So it's kind of backtracking to bananas. Let me see if I can change this so if I said print the range 1 to 4, and then I ran that cell again, see it prints bananas, cantaloupes, and dates. And again, if you're on Terra and you're using it, try not to run the code right now, because it might be generating some of these messages on my screen, and it's kind of slowing us down a little bit in the instruction. So anyway, here again, the tuple, let me hit 4 in there as that example again, run that cell. So apples, bananas, cantaloupes, and dates. And here we have apples, bananas, cantaloupes. Notice that it stops before value 4 and just prints bananas, cantaloupes, and dates. I'm sorry. Let's try this one more time. 3 would
Cindy, I sent you a link in the chat. So maybe you want to use that. It's a copy of it so that you're the only one using it.
Thank you so much.
Okay.
Okay, let me open that. Okay.
And the good news about Cindy getting all these error messages is that you guys are doing it along with her. That's great.
That's right. There's evidence that people are working along. That's great. So again, let me improve upon this example. So the first example is the full string of fruits tuple. The second example is just going to be value 1, which is bananas. And then the third example is fruits tuple with the values 1 through 3, but it's actually the item before 3. So it's 1 and 2. So let me just run that so that you can see the results. There we go. So that with repeating that example multiple times, you should at least get a sense of how Python understands ordered lists with this 0, 1, 2, 3 dates. But again, the code is here for you to refer back to if you take a break from coding and then come back, it's there as a reminder. So what we're going to do in this next example is look at loops, and we're going to create a list and run that list through the loop. Now, the difference between a loop and a list is order does not matter in a list. You can have the same variable multiple times in a list. And again, the order doesn't matter. They're in alphabetic order here, but they don't need to be. And you don't have to put tuples in alphabetic order. It's just that there is a very specific order, whether it's step 1, 2, 3, 4, exact, whatever. It's an immutable ordered collection. The other difference between tuples and lists are you use parens for tuples. It doesn't matter whether you use a single quote or a double quote, or you could even use triple quotes around your items, but you need to be consistent in whichever you choose. Just for variety, I used a double quote here. And then in this example, I chose to use a single quote. Lists do require that you use a bracket. So you have to use a bracket if it's a list. And then you can go ahead and run your list. So I created this list, again, our fruits, apples, bananas, cantaloupes, dates, and raisins. And when I take this list, I'm going to say for each item in this range of 0 through 0, 1, 2, 3, 4, 0 through 5, print the fruit list. And so I'll go ahead and run that code and see what that looks like. Let me see if this will let me just run. So there's my list of apples, bananas, cantaloupes, and raisins. And notice that the list generates an actual list. It's a vertical list of the items. Now, when I said print the fruit list, notice it's printing 4 times through the values of 1. Ooh. Through, oh. Let me get back to that section. Through the values of 1 through 4. So it's 1, 2, 3. Those are our values. And it printed them. So for I in this range, it printed that 5 times. The range is 5, so it printed it 5 times. This is probably not the intention of the code. The intention of the code was something more like this. So this might be a line of code that got written, but it's not right. So to fix it, you would do something like this. Whoops, lowercase I, because it has to be consistent. Case matters as you're coding. So then it would generate the list in the way that you want it, exactly as the one above. Okay. So just to point out, I've focused on tuples and lists, and I used a loop to demonstrate some of the logic that you can use within Python to loop through items. And I demonstrated a potential error by putting in that 1 through 4 example. Whoops. So again, we talked about lists and loops, and then again running something through through a loop. This section here talks a little bit more and gives you information about tuples, lists, dictionaries, and sets. These are the 4 main data types that you'll find within Python. If you recall our code above, we set the value of x and y. So if we look up here, so we said x is 4 and y is 2 times 5. So now we have an example of an if statement. So the if statement says if x is greater than y, print x is less than y, else print x is not less than y. So let's go ahead and run this particular cell. Okay, and I have an error message here. What's great about Python is it'll tell you exactly what the error is. So right now I'm thinking, okay, it doesn't have my values because this particular script is reloaded several times. So when you reload it, you have to reinitialize your code within your active memory, or your code's not going to run. So what I need to do is just make sure that this cell runs. And so now those values are back in my active memory. So if it closed out, then those values weren't there, but now they're back. We have 4 and 10. So knowing those values, I should be able to create this if statement and go ahead and run that cell, and it says 4 is less than 10. So that's great. Now, if that value in my code changes, like if I said y is equal to 2 times 1, I would have to rerun this particular cell to make sure that that value is changed in my active memory, and then come down here to my if statement and rerun that. And there it would give me the 4 is not less than 2. Okay, so yes, so somebody did try apples. Perfect. Okay. All right, so that gives you a little flavor of tuples and lists and conditionals like loops and if statements. Again, we're not going to become coders tonight or today, but with a couple, I'd say a month or 2 of effort and self-learning, you'll be able to do that. Let's see, it looks like other people have jumped on to that other area. So again, if you're using this particular notebook, please stop. So again, this is an example of a function, because once we have created some values, we can develop functions. So here I'm going to go ahead and define my function. By function, I'm going to call it pi function. And the value named within pi function, this is actually the parameter. Named is the parameter within this function. Then I'm going to use the print command and create a print statement. And I'm just going to say print the text hello plus whatever the okay, yeah, it's really hard to.
Cindy, would you like me to create another copy for you?
Yeah,
Okay, I will do that.
but let's not share it in chat. Can you send it to me through email?
Sure.
Okay, thanks. Oops.
You can send it to you through chat, just
Yeah, direct message.
Direct chat. Okay, perfect.
And I would invite everyone else not to use that the same notebook, or it will generate these errors.
You guys, it's just copies. So what Luca is trying to do is to give Cindy a copy that nobody else is on, so that she doesn't get the error messages. The copy that you have is exactly the same. So it's not like you're missing out on anything. It's just she needs to have a copy so she doesn't get error message by other people using it. Okay?
Okay, and Luca, I'll wait for that. In the meantime, I'm going to go ahead and describe this function. So in Python, you use a lot of functions. Actually, when you pull in libraries have tons of functions written in them, and it's code that other people have written and developed and tested, and they're tried and true. And so you can just use those libraries, and that's wonderful. And Debbie was talking about being able to do that here within Terra as well. But you can also create your own functions. And to create that function, first you have to define it just by using the def function itself, and then name it. And so I name this one pi function. And then you describe a particular, what is the word I'm looking for? Not variable. I'm sorry, I'm drawing a blank. One second, because I don't want to misname this. Parameter was the word that I'm looking for. So you need to create a parameter for it, and then this is just text, and then I've listed the parameter, and then just an exclamation mark for the end of that particular sentence, so that when I run that code, I'll go ahead and print, and I'll say, print these sentences, and then it starts picking up these particular parameters that have been named within the function that I defined called pi function. Let's see. So I'm going to go ahead and initialize the screen, Luca, and then switch views.
Perfect. Thank you, Cindy. And you can try playground mode.
Sure.
Okay.
Okay, terrific. I think I just did open. All right. So let's use this one. So that's a flavor of how you would create a function. And so again, if I went ahead and ran that cell, it should generate these particular sentences for me. All right, so now it's time for all of you to try your hand at this. So if you haven't already tried this in the exercises, go ahead and create a variable and just assign some text to the variable, and let me know if you run into problems or have questions, all of that. Let's see. Can we define, I'm going to respond to some of the questions that I see here. Can we define a function of reorganizing items in alphabetical order? You could. So if you wanted to, if you somehow wanted to reorganize the items in, I'm not exactly sure how you would write that code, but there's no like alphabetize this function. I might do that in Excel and then move that back into Python. That's how I would handle that one. There might be some code out there to alphabetize a list, and you might be able to find that just by Googling it. But can you define a function of reorganizing items in the alphabetic? So that's how I would approach that. I don't think I would write a function itself to alphabetize, but I guess it could be done. What is the exclamation part for? Just to end the sentence with an exclamation mark. There's no particular value in it. It's just part of the sentence that was written. Coding the exclamation mark at the end. Okay. Okay, so thank you. Items. What is a float? A float in a value number? You got an error message and it said a float. That is something that I'd have to look at your screen, and I'm not exactly sure what it's looking. It sounds like it's numeric, so I'm not sure that I can address that particular error message. What is a float object? Well, tell you what, some of these questions I'll have to, I'll get a copy of the chat and look at the precise answers that I don't know and send you responses to those answers. I would be interested to see how many participants were able to go ahead and work on the exercises and are having success with the exercises. If you could give me a thumbs up on that, that would be helpful to know. And also, if anybody has been able to complete them, creating that variable, printing text, assigning some different values, create a tuple, printing the values of the tuple, and try maybe just using the examples that I provided and creating your own values and variables. And again, if you've had success, I would be interested in seeing it thumbs up.
So what Cindy's asking you is if you've had some success in running any of this code or following along, to do a thumbs up. And you can do a thumbs up by hitting the reactions at the bottom of your screen. And it'll just show up on your picture. So hit reactions and select the thumbs up.
All right, I'm seeing a few good ones. Yeah.
This is Zara at the ICSC. Are we only to ask questions in the chat, or can we do so by voice?
You can ask by voice.
Okay, just a question about the list, the tuple.
Sure.
If you when you're working with an existing data and you want to make a list of, say, it's a 6x6 table or data set, and you want to make a list of the first 5 variables, then do you have to read in all the 6 to create the tuple?
So if you have a table, that's a different type of data. It's a data frame. And so that's actually a different type of data structure. And so we'll talk about those in just a few moments, because it sounds like your question really refers to a data frame and not necessarily a list per se. Lists are
Okay,
small.
so the
small
example
items.
that you provided is we were looking at one variable and all the list of variables that are measured by that particular variable.
We're just looking at a list of items created as a single line data structure. Does
Okay,
that,
single line.
yeah.
And that single line can be, the single line is both horizontal and vertical data?
No,
Or
I would say it's just
only
horizontal.
horizontal data? Okay.
Horizontal. Yeah. Knowing that, let's kind of move on. It looks like a lot of people have had success with the exercise. So let me go ahead and get back in
Thank you.
this particular site. Luca, that direct link went down as well.
Oh, you just have to log in again. Or actually, yeah, I see a window in the background, right? You could use that.
Okay, that's the one that kept crashing, but okay.
I think he has to sign in first.
Okay, let me. Oh, thank you.
Mhm.
Let me just go to this reload. And when you say sign in, oh, it's not here. Let me. Really locked up here. Let me.
Would you like to just open a new window?
Yeah, that's what I'm going to need to do. It looks like I've timed out completely. Let me try just refreshing. Terra. And sign in. Okay.
Yes.
Then workspaces.
Actually, Cindy, I'm just gonna send you the same link.
Okay, thank you.
Easier.
Okay, I have the same. I had it open, so.
Perfect.
Okay. All right, so that was an excellent question about really kind of alluding to the concept of data frames. So congratulations to all of you who were able to complete the exercises. You've already coded, so now you know Python. So we'll go ahead and move on to our next example. And the way that I think about this example is I was taking dance lessons, salsa lessons, or cha-cha lessons. And so our first lesson was, forward step, to the right, cha-cha-cha, backward step, to the left, cha-cha-cha. So those basic coding steps that we did up above, that's that basic lesson. But with 2 or 3 more lessons, and in this particular example, this code was created by my classmate when I took Python last year. So this is an example of what you can do once you've invested the time, the energy, and the effort to learning Python in a month or 2. And so I'm going to use with her permission, I'm using Joyce Thompson's code from NICHD. And again, you can automate reports and reflect results from data sets. In this mock example, we used just some data sets that were out there on Google Data. This is looking at patients with or without a diagnosis of cancer and their reported exposure to either smoking or glyphosate use. So the first thing that we need to do to begin this part of code, this session of code, is to, again, import the packages that we need and mount the drive that we need. And this one was done on Colab, and that's why you would need to mount the drive. But we're here on Terra, so that's actually not something that needs to occur. So we'll import pandas as PD, just short for pandas, so that we don't have to write pandas every time that we want to use that code. And we're going to import numpy as NP. And again, that's just shorthand for numpy. So we don't have to type that name every time we want to use codes. And then we're going to import intertools. Now, just to kind of back up and explain what each of these items are. So NumPy is actually just a math fundamental package for scientific computing with Python, and it's frequently used with pandas and visualization packages. And then pandas, the pandas library performs math calculations to work with analytical steps. And there's tons of information out there. If you just Google actually NumPy, you'll find a website that will give you all kinds of information about NumPy if you're interested. If you want to look at pandas, the same thing. There's tons of information out there about pandas. So we'll go ahead and run this code.
Cindy, I just want to add
Mhm.
that if you're working in the scientific field, you pretty much always want to upload pandas and NumPy. Always.
Yeah.
And the minute that you start wanting to work in Python, these are like structures that help you more easily code. So just always upload pandas and NumPy.
Yep. They're staples in Python for sure. So then this next cell here is reading in this data set that Joyce created. So it's just data, and Joyce used her initials. And then it's saying, read this panda, PD, remember we called it PD up here, PD dot read my CSV file, just your basic Excel file that you've exported as CSV and then imported into your active memory for your Python code. So this is just giving the path that we initialized way up above at the top of the code. And so it's just reading in that particular file. And then this next line of code says, take this data set, JT, and perform .head, perform this function head. And what the function head will do will just simply print out the first 5 lines of that particular data set. So here are all of my columns in the data set, all of my fields, and then each row or each value for each data set. So hopefully that addresses the earlier question about that came up during lists, because again, that was just a list.
Good afternoon.
Hello. So anyway, so this is an example of a data frame. This next line of code will go ahead and look at all of the data types within that set. Now, this next cell here is going to count the number of patients that have lung cancer. So again, it's using the data frame, it's creating another sub data frame for lung cancer. And then it's going to count the value and then print that information. So I'll just go ahead and run that cell. And let me just make sure that I ran these cells. Might have just been a little bit too busy talking to actually run them. Because this cell below, this code will not run as above. Remember our example earlier, I tried to run that query and it won't run unless the previous code was in active memory. So now I have a value and not an error message. And that happens frequently. Sometimes you just need to go back and reinitialize your code or rerun a cell, and then your code, instead of having an error message, will go ahead and run properly for you. So here is a very similar set to above, looking at the number of patients that don't have lung cancer. Then we're going to slice the data by lung cancer status in this particular cell and run that. And then we're going to count within the people with lung cancer using a forward loop. Remember, we had a loop example before. This is a little bit of a more complex loop, but you can write this code really with some effort, a little more knowledge about syntax. This is just a basic loop, and you can produce this type of information for your own research and data. So here we have a count with people. We instead of having to calculate all of this up or transfer it from Excel files, here we have some totals and some information about our data set. Same with this next cell. And so we have more information about females within our data set. Then we'll look at males within lung cancer. And again, we have some valuable information about that data set for those that have lung cancer or do not have lung cancer, I'm sorry, and females that do not have lung cancer. So then Joyce asked the next question, is there equal representation within the different categories? So you can categorize using your if-else statements by gender, age group, smoker, or glyphosate user. And here you just, if the gender is 1, then you sum that total. Else, cancer group has more females. Same with smoker, same with glyphosate users. So I'll go ahead and run those cells. And at the bottom of that cell, it's a long cell, but you get these value statements. It was able to determine that the cancer group has more males, the cancer group has more smokers, the cancer group has more glyphosate non-users, and the control group has more males as well. The control group has more smokers, and the control group has more glyphosate non-users. But some age groups may have an equal number of people with lung cancer. The control group has more people between the ages of 65 and 74. So now how do we visualize that information? So we need to import a couple of additional libraries. We imported sorry, I'm going back up here just to demonstrate. We imported pandas and NumPy up here, as well as intertools. They were all libraries that we needed to run that code. The code would not run without those libraries. So now we're going to import 2 visualization packages, Seaborn, and Seaborn is actually born out of Matplotlib. These are both visualization tools. So I'll go ahead and run that. Notice that we set Seaborn to SNS and Matplotlib is PLT. So we'll go ahead and run those cells. We're going to use a style called white grid within Seaborn. And we're going to go ahead and plot the lung cancer positive data set. And so here you have lung cancer by age group, a visualization in a violin plot. The next cell down, if we run that, again, we're using white grid within Seaborn. And just by changing a few attributes in the code, we're able to get this next visualization. Something didn't run. Go back and run this cell again. So there's my lung cancer plot. And there's the control group plot. And again, note that it didn't run properly the first time. I just went back, made sure the prior cells were run, and then it ran just fine. All right, so that's one example for my classmate. But I wanted to point out to all of you that there are a lot more visualizations that you can perform. So I'll go ahead and initialize all of these libraries in my active. They're active now, but we keep kind of stopping and starting. So I'll go ahead and reinitialize those. And now I'm pulling in a different data set. This is the iris data set. And I'm just, again, reading it in a .csv file. It's just that easy to pull in a .csv file. You name it and then give it the directory path and you pull it into your active memory. Then we're going to look at the head of that using the head function. We're going to look at the first 5 cells. So we'll go ahead and run that. And here we're using strip plot, the strip plot function. within ScHARe. This time, notice that ScHARe is SB, not SNS. Just a differentiation in code. That's it. Just there's no other significant difference. But SB strip plot, we named our x-axis, our y-axis, and the data set is iris. And there I have a scatter plot, just that simply. Then I can also go ahead and change that just by changing it from scatter plot to box plot. It creates this visualization for us. And same, just by changing it to hist plot, it'll change the visualization. I think the value here is petal length is different. Nope, it's the same, sorry. So it creates this visualization. So let's go ahead and have some fun with these visualizations. So go ahead and try your own skill. Kind of take some of these visualizations below and see if you can create your own or create variations in them. You can try changing the graphs, anything that you want to do. So whatever you choose to do. And I'll respond to questions in the chat.
She can also answer questions if you want to voice them. There's a question, Cindy, that asks for, is there a library that is used for visualizations?
So yes, so ScHARe as well as Matplotlib are two libraries that you can use for visualizations. There are a few others as well. If you just go to that PyPy site, you can find other visualization packages as well. But I would say that ScHARe and Matplotlib are the most frequently used visualizations. And yes, the whole purpose of this is for you to just see the demonstration. Someone asked, do you have time to digest the code and then come back and play in this space? And that's exactly what this space is created for. So I understand you can use, there was a question here. It says, this is a lot of code to understand, very short time. I'm sorry.
Yes, we do leave the platform open for about 24 hours, so until tomorrow. So you do have time to go look at it. You could also cut and paste the library, the text, and just put it on a Word document, or use it for yourself.
Yes, you can. You absolutely can cut and paste that code. You could use it in Colab and play with it in Google Colab. So I had a question before about the code that Joyce Thompson's code that were the I and J in the functions. So those were variables. Remember, to run through that loop. So one of the variables was just I. Remember, we used I for item in the previous loop that we worked with. So she needed a second variable in her loop. So she just simply chose J because it's the next letter in the alphabet. So yes, a lot of the work you could do in Excel. Honestly, I tend to use tools that I know how to use. So often if I know how to do it easier in Excel, I'll do something in Excel and then transfer it back to Python. I'll get it to a point in Python. I'll import it into Excel and say, I know how to do that better in Excel.
I just want to make the point that, what we what Cindy showed you today are basic sort of Python code. Yes, you can do this in Excel, what she showed you today, and you can do many of these things also in any statistical package. But this was just to get you familiar with the code, because this is not necessarily everything that Python does, but it just helps you to start to experience the terminology and the variables and what the language looks like, what the code looks like.
Exactly. Thank you. Thank you for that. Because ultimately the goal is to create your entire data set and code and all of that in something like Jupyter Notebook, so that you can document with rigor and reproducibility your research, your investigation. And there are actually ways that you can even generate a paper. That's something that I'm working on learning now myself as well. So it's a way to keep things neat, organized, and make it in one-stop shopping. But learning the basic code is the first step. And as Deb said, this is just some general familiarity to give you familiarity with concepts within coding Python.
Yeah, this is not what Python is. Python is so much more than this. So I don't want you to get the misnomer that, oh, I don't have to learn Python because I can do this in Excel. No. So I just want you to keep that context in mind, that this is just very elementary. And so you can eventually, if you learn Python, you can also see that you don't always have to use Excel spreadsheets and the other statistical packages, because you can do everything right here in the cloud space.
Right. Just to demonstrate briefly, so this code here in the window, that's not code that I wrote. I copied and pasted that from an example on Seaborn. So I'll just go ahead and run that cell just to demonstrate. Let me just make sure I have everything initialized that I need. Oh, because my other code up here, remember I had changed Seaborn to SB. I need to actually reinitialize Seaborn as SNS for that code to run successfully. So again, just by knowing a little bit of Python, it will help you troubleshoot your work. So I'm going to go ahead and rerun that as SNS and scroll back down to that other visual example.
And for those of you, as she's doing that have been with us before, and we're through some of our Terra sessions, you know that we have many notebooks that are on the ScHARe platform, and many of those notebooks have different codes, Python codes, cells. So all you have to do is change a variable name and you can run it, just like she's taught you to run these. So it's really easy to cut and paste and run.
So here's a simple box plot using that iris data set. And again, I didn't code this. I copied this from an example from Seaborn. Here's another example of Seaborn using a pair plot. So you can create some really terrific looking visualizations using these Python libraries.
And by the way, you can also look on a website called KDK, as in King, D as in Debbie, Nugget. And they also have code that's already been written. And you can also oftentimes Google code. So like if you want to like do something like a box plot, you can Google Python code for box plots. And you'll see that people have already done that and posted it. So as Cindy is saying, all you have to do is cut and paste it and use it. But remember, when you do this, you need to, these are like standards, always do. Jupyter Notebook, Pandas, NumPy, always initiate those, because they're always what you need for research to do this. There's a comment in the questions to talk about Terra and AI and big data. One of the reasons that we use Python instead of just statistical packages is because sometimes the data that we're going to be accessing is in terabytes and petabytes and zettabytes. And Python and clouds can handle that much data. That much data cannot be handled on your laptops with statistical packages, because there's just not a space for that kind of data quantity. So that's what we mean by big data. That big data is ascertained in many ways. It can be from aggregated data sets. It can also be things like social media feeds, because they generate tons of data every minute. So part of the reason that we use the term big data, it's because we're talking about large quantities of data. The Terra platform is what we call an interface. So, and the background on a cloud is basically Google, AWS, which is Amazon, or Azure, A-Z-U-R-E. A lot of education institutions use Azure. There's pros and cons to both cloud platforms, all three cloud platforms. They do almost the same functions. Some of the differences in a little bit in cost and storage, and other differences are in what data sets they host themselves. But you can't go wrong, because they're all doing exactly the same thing. What Terra is, it's an interface into that. So the interface is what allows you to have these secure workspaces and store code like the Jupyter notebooks. Notice the word workspace up on the screen. It allows you to do all kinds of functions with the data that is on these cloud platforms. We have spent much of the Think-a-Thons prior to this to teach people how to use Terra. You could, if you've never done it before, you can go back to our web pages and review every session that we covered. There's also slides there. The next Think-a-Thon, Luca is going to summarize everything that we covered in the last year on Terra, sort of to walk through and to remind people how to set up their workspaces and download data into their secure workspace. And then again, next year, we're going to start again from step one and repeat the whole cycle. So there's many different ways to get caught up in what Terra is. So I see Cindy's running some code and stuff, so I'm going to turn it back over to her.
Sure. So I was preparing and trying to fix this code here. Just to point out, I went back and I reloaded Seaborn and Matplotlib and my data set, just to make sure that code ran properly, because I was having problems with this cell further down below. Notice this nice scatter plot, again, using Seaborn lib, and then this cell. Here's just a basic his plot, a pair plot.
Sarah again at the ICSC. Just
different. Excuse me. Here's a different pair plot And this one was giving me a little bit of trouble here. So let me see if I can go ahead and run that cell. And again, just some examples to give you the different, I think the systems might just be running.
Cindy, you can show them the code to run it.
Yeah. I think it's just running a little slowly right now, but this is the code. And really, I just copy and pasted this code from known examples of using Seaborn.
Just another quick from CSE. It's wonderful to have the visual in line, so to speak, with your exporting the sections a part of the next
Exporting data. So I didn't prepare anything to export. Do you typically allow folks to file export files?
the visualization.
Yeah, I put it into the chat. You can upload your own data into your workspace. We're going to go over all of this the next Think-a-Thon.
Next one. Okay.
Yeah, so we're going to summarize what we did over the last 6 Think-a-Thons so that people can have like a little overview, especially for those of you who have been with us each time. And for those who haven't been with us each time, it'll kind of give you a sense of what to do. We're not going to go as slow as we had in the past, but also know that all of these instructional tutorials are posted on the NIMHD webpage. And Mark and Kevin have put that in the chat a few times.
Great.
Okay. So is there anything else you want to cover, Cindy?
Nope, I am finished. That concludes my demonstration. I hope everybody found some value in seeing different kinds of code and different terminology within Python. And I hope everyone goes and pursues and learns how to code. Someone had made a comment about, can you just code from AI? You can, but you know, as librarians, we always say consider the source. So my caveat to that would be know your source material. If you're building your own AI or it's an AI built by people that you trust and know, then sure, why not? But if it's not an AI that you trust and know, then you know you're not on solid ground about your, you know, how things are being generated.
And that is kind of what she pointed out is that whole ethical AI issue. And oftentimes it's just like any other process. When it's built for one purpose and then you try to repurpose it, it doesn't always work. So you have to be able to know enough code to know how to make it work for something different or to keep it ethical. So we're coming to the close of the session. Are there any last minute questions, either for Cindy, Luca, or myself?
May I ask you if you could please leave the platform for more than 24 hours? Because it is only now I can access it so that we can have time to get them, because this is so important. I would like to copy the codes and run them after that.
It's kind of our policy to close it tomorrow afternoon. So you can always go in and open up your own account. It's free. You get a $300 credit when you do that. And then you can create your own workspace. So we are available to help you do that. You can send a message to me or to Luca. And so it's always available to you. It's not like this stuff goes away. It's always there.
Okay. Thank
Okay.
you. Thank you.
I want to turn this over to Kevin now. one of the things that we ask you to do is to fill out this last Slido. It's an evaluation to look at what we provided, the information we provided for you today. It's important that you give us the feedback so we know how to structure these in a different way. We always run into spending so much time registering people that didn't pre-register. And so that's why we changed our approach to pre-register you as much as possible. Hopefully to cut back, because like last time we had to register over 150 people. And it's just impossible to do. So if you could please give us feedback, we will do things to help improve what we do. And we want to improve because we want you to be involved and to learn data science, use the ScHARe platform, and advance your work in research using big data. So Kevin, I'm going to turn it over to you.
Okay, you should be seeing the QR code for the survey, and I believe Mark put the link in the chat for Slido, and so please just go ahead and fill out that survey. I will leave it up even after the Zoom closes, just so that people can continue to fill it out and provide that feedback even after we close the Zoom.
So as soon as you fill out the survey, you're free to log off. Keep in mind that we will post the recording and the slides in about a week on our webpage, the NIMHD Think-a-Thon webpage. So you're always there free to go back and listen to and see anything that you might have missed. Okay.
Deborah, can you put that on the chat, the link to where the recordings will be?
Yeah, Kevin or Mark will put the link in again.
Okay, thank you.
So
Yeah,
Mark just did. That's the NIMHD Resources ScHARe Think-a-Thon. So that's where you can go to get all the recordings
Okay,
and all the PowerPoints.
okay, thank you.
I also wanted to point out that everything, so including this notebook that we use today and many more, is always available to you. Okay, at the link that I will paste in the chat in a moment, because you're now registered for ScHARe. So the only thing that you wouldn't be able to do after tomorrow, when access to the free billing project expires, is actually running the cells and performing the computations. So if you want to do that after tomorrow, you have to create your own billing account, and we do provide those instructions on our website. And you can also leverage the $300 in free credits that Google offers each user. So you can use those towards that. And I'm going to paste the link in the chat where you can find all our notebooks so that you can review them.
And the other important thing about today's slide set, once it gets posted, the slide set also has how to set up your billing account. So it's a very step-by-step instruction that even I can do by myself. So if I can do it, you guys can do it. And that will be, we just didn't cover it today, but it is on that slide set. And also on that slide set is how to upload your data into your workspace. So there's 2 additional concepts that are on the slides that we didn't cover today: billing and uploading your data set. So come back and look at it. And once you've filled out the survey, you're free to go to your next Zoom call.
Okay. Right.
Thank you for the claps
You're very welcome.
and the hearts.
Thank you to all. Thank you.